Welcome to our deep dive into the fascinating world of research hypotheses. You see, in the vast universe of knowledge, hypotheses are like stars guiding us through the darkness of the unknown. They're the starting point of any scientific journey, the questions that spark our curiosity and drive us to explore. Today we'll explore the different types of hypotheses that form the backbone of scientific inquiry. From the null hypothesis, which assumes no relationship between phenomena, to the alternative hypothesis, which dares to suggest a connection, we'll unravel the mysteries of these fundamental building blocks of scientific thought. So buckle up, fellow knowledge seekers, as we embark on this exciting exploration of hypotheses. Let's start with the null hypothesis, often denoted as H0. Think of it as the no-effect assumption. It's like saying the Earth is flat before we had the evidence to prove otherwise. Now, this doesn't mean the null hypothesis is always wrong. It's just a starting point, a baseline against which we compare our observations. If our experiments show strong evidence against the null hypothesis, we might reject it in favor of an alternative explanation. It's like when Galileo pointed his telescope at Jupiter and saw those tiny moons orbiting around it. That observation challenged the null hypothesis of an Earth-centric universe, paving the way for a revolution in astronomy. Now, this is where things get interesting. The alternative hypothesis, denoted as H1 or HA, is our contender, the challenger to the null hypothesis. It's the scientific equivalent of saying, hold on a minute, I think there's something fishy going on here. The alternative hypothesis proposes that there is a relationship between the variables we're studying. It's like saying maybe the Earth is round after all, and then setting out to find evidence to support this claim. The beauty of the alternative hypothesis is that it opens the door to new possibilities, to exciting discoveries that can change our understanding of the world around us. Imagine you're an explorer venturing into uncharted territory. You have a compass, a sense of adventure, and a hunch about where you might find treasure. This hunch, this educated guess about the direction you should head in, is akin to a directional hypothesis. In scientific terms, a directional hypothesis predicts not only that there's a relationship between variables, but also the direction of that relationship. It's like saying, I believe that if I travel east, I'll find the lost city of gold. Of course, in science, we replace lost cities of gold with more concrete concepts, but the principle remains the same. We're making a specific prediction about the nature of the relationship we're investigating. Chapter 4. Now, let's say you're still that intrepid explorer, but this time your compass is broken. You know there's something out there, something worth discovering, but you're not sure which way to go. This, my friends, is the essence of a non-directional hypothesis. It's like saying, there's definitely something interesting happening here, but I'm not sure if it's up, down, left, or right. We acknowledge the possibility of a relationship, but we don't make any specific predictions about its direction. It's like saying exercise affects sleep without specifying whether it improves sleep or makes it worse. This type of hypothesis is especially useful when we're exploring a new area of research where we don't have enough prior knowledge to make a directional prediction. Chapter 5. This is where our scientific journey starts to take shape. A research hypothesis is more than just a hunch. It's a well-articulated statement based on existing theories or previous research findings. It's the culmination of our curiosity, our observations, and our understanding of the field. Imagine you're a detective piecing together clues at a crime scene. You're not just randomly guessing who the culprit might be. You're using evidence, logic, and your knowledge of criminal behavior to formulate a hypothesis. Similarly, in research, we rely on the scientific method, previous studies, and established theories to develop a research hypothesis that can be tested through rigorous experimentation. It's about connecting the dots, identifying patterns, and proposing explanations that can be put to the test. Chapter 6. Now, we're entering the realm of statistics, where we put our hypotheses to the ultimate test. A statistical hypothesis is a formal statement about a population parameter, something we're trying to estimate or understand about a group. Think of it as the courtroom drama of the scientific world. We have our null hypothesis, the defendant presumed innocent until proven guilty, and our alternative hypothesis, the prosecutor presenting evidence to challenge that innocence. Through statistical analysis, we weigh the evidence, calculate the odds, and determine whether we have enough grounds to reject the null hypothesis in favor of the alternative. It's all about using the power of numbers to make informed decisions about the validity of our hypotheses. Ultra. And there you have it, the different types of hypotheses that guide scientific research. From the null hypothesis, which serves as a starting point, to the alternative hypothesis, which challenges the status quo, these statements form the bedrock of scientific inquiry. Remember, a good hypothesis is testable, clear, specific, falsifiable, and based on theory or prior research. It's a testable prediction, a tentative explanation that guides our quest for knowledge. Thanks for watching, and stay curious.